Hi there, I have a convergence problem which is actually a subset of harmonic series, and instead of adding all of the reciprocals of n, we won't add the ones that has a 9 in it. For example, we won't add 1 over 9, 1 over 19, 29, 39, 900, 905 anyways. And so, well, if you know, harmonic series is actually divergent if you add this instead of all, like excluding the ones that has a 9 in it. If you add all of them, this is divergent, and this is very slowly divergent, which makes it the worst series ever. It's the most annoying series. Let's talk about this for a second. So for example, if I add 1 terms, it's of course 1. If I add 10 terms, it's about 3. 100 terms, it's 5. 1000, 7.5, 9, 12, 14, 16, 18. If I add billion terms, after this point it's very slow, it gets only 21. I mean, this is very slowly. Like, imagine how many terms it would take to pass, for example, 100. You can actually calculate those stuff without a calculator, or I mean just one step calculating without adding that many terms. So this series is diverging very slowly, and so if I exclude a term that has a 9, all of the terms that has a 9 digit as 9, this convergence, which is surprising. So let's see. So I'm just gonna think digit wise. So I'm gonna think about the terms that has only 1 digit, and I'm gonna denote it with S1. So S1 is gonna be sum of all of the numbers that is from this series which has 1 digit. So it will just be 1, 1 over 2, 1 over 3. So it will just go up like this, up to 1 over 8, and I won't have 1 over 9. So S2 will be the numbers that is from this series that has 2 digits at the reciprocal, at the denominator. So it will start from 1 over 10, 1 over 11. So it will just go up like this, pop, pop, pop. So it will go up to 88. Well, it won't have anything after 90 or 89. And similarly, I can just define Sn. So Sn will be, so, well, when I have 2, this is just 2 minus 1. So this will just be 10 to the n minus 1. So that this is n digits. And it will just go this thing plus 1, plus 2 anyways. So this will just go like this. Okay, cool. And now my goal is to find nice upper bound for all of this stuff. So first of all, I will try to count how many terms are in Sn. So for example, I will just try to write all of the alternatives. So imagine this is an n digit number. Okay, I will see how many numbers I can write with n digits that doesn't have a 9. So the first digit can't be 9, but also it can't be 0 because it's the first digit. It wouldn't be n digits. So the first digit has 8 options, and all of the other terms can't only be 9, and it can be anything else. So there are 9 options for all of the other ones. So I have so the total number of terms that in Sn is just 8 times. So here I have n minus 1 terms, 9 to the n minus 1. Okay, cool. And now I'm going to use this thing to find upper bounds. So basically, well, 1 over n is of course decreasing. So all of the terms in Sn is just less than the first term. For example, all of the terms in S1 is less than 1. All of them are just less than 1 over 10. And this way, I'm just going to get something geometric, you can see. So for example, this thing will just be less than 1 times. So there are 8 terms. And for this one, so this will be, so all of them is just less than 1 over 10. And I have this many terms. If I put n is equal to 2, this will be 72 times 72. And in general, this will just be 1 over 10 to the n minus 1 times, so this will just be 8 times 9 to the n minus 1, because I have this many terms and they're all less than this. Okay, so I basically pick the biggest term and say this is less, because yeah, I found an upper bound. Also, a note here that so if this thing is convergent, well, I don't know if it is, but this would be same as so let's just say n in A, whatever, 1 over n, So this is actually same as adding all of these stuff up, right? If you add the terms that has 1 digit, 2 digits, up to n digits, and if you take n goes to infinity, of course this will just be equal to our required sum, Sn. And if I call it S, okay? So if S exists, S should be sum of all of the terms, that is just Sn, okay? If I have all of the Sns. And here I found an upper bound for Sn. So this thing is less than something, and if I add them, the sum will also be just less than their sums. N greater or equal than 1, it will just be this thing. Sn is less than this thing. So I can just take the 8 before and combine these two. So this will just be 9 over 10 to the n minus 1. Okay, well, now just to make it nicer, I can put n is equal to n plus 1 here. So it will be n greater or equal than 0. So it will be 9 over 10 to the power n. And well, now this is just a basic geometric series which has increment of 9 over 10, which is less than 1, so it's convergent. So it will be 8 times 1 over 1 minus 9 over 10, which is just going to be 1 over 10, 10, 80. Okay, cool. So what does that mean? So I found that Sn is bounded above the sum of Sn. And also if I think, so basically, Sn is actually increasing. Why? Because so if I think Sn plus 1, if I add Sn plus 1 to this sum, imagine it's like partial sum, it's finite. If I add Sn plus 1, which has only positive terms, so actually if I add, for example, let's say k is from 1 to n, sk is of course less than k is from 1 to n plus 1, sk. So this is just increasing. And also I found that it's bounded above any sequence that is increasing, which is here, and also bounded above is convergent. So this Sn, sum of Sn, is convergent, and we just said that this is just gonna be S. Of course, to find some, we can solve it like this way. We only showed that it's convergent. You would need much different methods to do that, and I'm actually not sure if they solved this sum with analytic ways, I mean without numerical ways. So this shows that S, which is our series, convergent. And that's the end of it.